Hi Chan, so let's see this question. A question is saying that a truck covers a distance of 3 km at a certain speed and then covers another 4 km at a speed 20 km per hour greater than the original speed that was before. If the truck takes 10 minutes to cover the total distance, okay, then can we represent this situation using some equation? Can you do it? Let's see and let's figure it out. Champ, welcome into another amazing session, and I'm your master teacher Shivam Gupta, and in today's class we are going to discuss about the quadratic equation. So let's get started, champ. So in this class, first of all, we will see that what are the quadratic equation and what is the standard form of the equation. Then we will see that what are the different real life situations where we can form the quadratic equation. Then we will see that what are the must condition for the quadratic equation, then what is the meaning of the roots of the equation. So let's get started, champ. First of all, we have already discussed that what are the polynomials, and when we were defining the polynomials on the basis of their degree, we saw that if the polynomial have a degree 2, then the polynomial will be my quadratic polynomial. Now champ, if I will equate the quadratic polynomial, if I will equate my quadratic polynomial to 0, like, let me show you, like this. The left hand side is the quadratic polynomial. Then I have equated this to the 0, right? Now all of these equations are nothing but my quadratic equation. Equate means equation, right? The degree is 2. That's why quadratic equation. I hope it is clear. Very good. Okay, champ. So we can see that how we can define the standard form of any quadratic equation. So we can see the first term is of the form of ax square. The second term is of the form of bx, yes, and the last term is nothing but the constant, which can be represented by a small c, right? So that means we can say that for any quadratic equation, the standard form is what? Ax square plus bx plus c equal to 0. Yes or no, champ? Very good. So this is the standard form of any quadratic equation where a, b and c are the real number, and the must condition is what? Must condition is that the coefficient of x square cannot be 0. Okay, this is the must condition. If the coefficient of x square is 0, then that won't be my quadratic equation. I hope it is clear. Very good. Now, champ, let's see some real life situations also. So let's see that in which case, in which situation, a quadratic equation pop up. So the first example which we have seen in the starting of the class, that if a truck covers a distance of 3 km at a certain speed, then cover another 4 km at a speed of 20 km per hour greater than the original speed. Now, if the total time taken is 10 minutes, so we have to represent this situation with the help of some equation. So, champ, let's say this is the situation. A truck is going with the speed of x km per hour in the initial phase, right? Then after 3 km, speed is x plus 20 for next 4 km. So now we can see the initial speed is x. So final speed will be x plus 20. We know the distance covered, right? So we can write the time. We can write that the time covered, time taken initially will be distance upon speed. Next 4 km time taken will be distance upon speed equal to total time taken. It was 10 minutes. So I have converted 10 minutes into hours. That's it. So now, champ, let's take a LCM. After taking the LCM, look at the denominator. X into x plus 20. So it will become the quadratic equation. I hope you are getting it. So that's the equation which is representing the situation. I hope it is clear. Very good. Excellent. Okay, champ, so let me show you one more real life example. Look at the question. If there are two pipes running together, can fill a tank in 11 and 1/9 minutes. If one pipe takes 5 minutes more than the other pipe to fill the same tank, then find the equation required to find the time in which each pipe would fill the tank. That means we have to make the equation in the form of time variable. That's it. So champ, let's assume the pipe A. There are two pipes, pipe A and pipe B. Pipe A is taking the time x minute to fill the tank. So the pipe B will take the x plus 5 according to the given information. Now, if the pipe A is taking x minute to complete the work, right? So for 1 minute, the work will be done by pipe A will be 1/x, and same in 1 minute, the work done by pipe B will be 1/x plus 5. Now, what is given, champ? It is given that together they take this much time. That's it. Simple. Add these two equal to given time, right? Now simply take the LCM and you will get the quadratic equation in the variable x, and x is the time. That means we got the time variable in the form of quadratic equation. I hope it is clear. Very good. So champ, there are many examples in the real life where we have to use the quadratic equation. Now, one question comes, champ, to think it about that does every quadratic equation which has x square is a quadratic equation? That means if any equation, if any polynomial is a quadratic equation, so is it the complete condition that if there is a x square term, then that equation, that polynomial will be a quadratic always? Let me show you one example. Let's say, champ, look at this question. The equation is 3 root x minus x square equal to 1. They are asking that whether it's a quadratic or not. What to do? First of all, let's write in the standard form. Now we can see there is a x square term. So we can say the coefficient of x square is not 0. So it is quadratic. Yes? No. Why? Because there is a term of under root of x. The power of the variable here is not the whole number. That means it is not even the polynomial. Right? It is not even the polynomial. So quadratic equation is not possible. It is not even the polynomial. That's it. So remember the condition. First of all, it has to be polynomial. After that, check for the x square term. Okay? Very good. Now, champ, look at this. We have to check out that whether this equation is a quadratic or not, because the power is 3, I can see. But we cannot decide until my equation is in the standard form. So first of all, let's convert this in the standard form. So champ, after simple opening of the cube, we got this equation. X cube will get cancelled out, and I will get a quadratic equation where coefficient of x square is not 0 and all the constants are real value. So it's a quadratic equation. So always convert first in the standard form. Okay. Now, champ, let's see the roots of quadratic equation. So champ, let's say we have a quadratic equation. Okay. Now, if in this quadratic equation, we will put x equal to 1 in the left hand side. Let's see what we will get. So after putting x equal to 1, we are getting value 0. That means LHS coming out to be equal to RHS. So for any value of variable which satisfy the equation, that value is nothing but the roots of the equation. Whether it's a quadratic, cubic or linear. Could be anything. Okay. So now, champ, let's summarize our class. So in this class, we have seen that ax square plus bx plus c equal to 0 is the standard form of the quadratic, where a cannot be 0 is a must condition. Then we have seen the roots of quadratic equation, right, are what? the value of the variable which satisfy the given equation. I hope it is clear. So champ, that's all for this class. Don't forget to practice and happy smiling and be healthy and be safe and keep smiling. Bye-bye.